All right, so here we are on page two of notes. So for the first couple problems, it says find the area in the perimeter of the following composite figures, give an approximate answer rounded to the nearest tenth. So we don't have to worry about doing exact answers. We just have to find an approximate answer for both the area and the perimeter. So for this first shape, this first composite figure, I want you to pause the video and I want you to ask yourself, what two shapes could you possibly divide this figure into? So go ahead and pause the video now and answer that question. Okay, so if you're like me, I see that this shape can be divided into, if I draw a line segment right here, and actually let me go ahead and do that. If I draw a line segment right here, this shape right here turns into a rectangle. It kind of looks like a square, but I know that it's a rectangle because the sides are not equal. We have a side length of 4 and we have a side length of 5. Therefore, it has to be a rectangle. It can't be a square. The other shape I see is that this looks like a half circle or half of a circle. And in math, a half circle is referred to as a semicircle. So if you look over here, I've written out, I abbreviated area as A. And I said the area of the rectangle is going to be equal to the base times height. If you think back to our formulas before spring break, that's our formula for the area of a rectangle, base times height. So I'm going to go ahead and write that out. So the base is 4 and the height is 5. Therefore, the area of just the rectangle is 20. Now, we just learned on the first page of notes that the area of a circle is equal to pi r squared. But in this case, it's only a half circle or a semicircle. So whatever that value is that we find, we're going to divide it by 2. So look at our diagram or our figure and ask yourself, what does it appear that the radius is? Well, in this case, it looks like it's 4. So that's what I'm going to plug in. I'm going to say pi times 4 squared over 2. If you take 4 squared, you are going to get 16. So 16 pi over 2. And then if you divide 16 by 2, you are going to get, let's see if I can squeeze this in here, you're going to get 8 pi. So we just found the area of the rectangle, we found the area of the semicircle. Now all we have to do is add these together and round to the nearest tenth. So it might be tempting to just say 20 plus 8 pi, that's going to give you 28 pi. But you can't add this value and 8 pi like that because they both don't have a pi. If this had a pi on it, 20 pi plus 8 pi, that is in fact 28 pi. But this doesn't have a pi symbol by it, therefore you can't do that. So instead, just go to your calculator and you're going to type in 20 plus 8 pi. And to the nearest tenth, that is going to give you, the area is approximately equal to 45.1. And because there's no units that are noted in the diagram, we're just going to say this is a U. We're going to say 45.1 units squared is approximately what the area is equal to. Okay, the next thing we're going to find is perimeter for this figure. So I want you to pause your video again and I want you to think about how could we possibly find the perimeter for this figure. All right, and we're back. So I have some of these calculations written out for the perimeter over to the side, but ignore those for the moment and look at the figure with me. So what I asked myself was, I said, which of the sides do we already know? And so here's what I was able to identify. I said to myself, if the length of this side is 5, well, then I can reasonably say that this length over here is 5. So far, it appears to me that we have 4 known side lengths, a length of 5, 4, 5, and 4. And that's how I've set up the problem, or I've represented it on this first line by saying 5 plus 4 plus 5 plus 4. And then if you're staring at this next part and you're like, well, where in the world did he get that from? That comes from the fact that the formula for the circumference of a circle is 2 pi r. But in this case, again, it's a semicircle. It's not a whole circle. So I'm going to divide this value by 2. On my next line, I simplified 5 plus 4 plus 5 plus 4. If you add these 4 numbers together, you're going to get 18. I plugged in 4 for the radius. 2 times a radius of 4 is going to, well, let me slow down. So I said 2 pi 4. 4 is the radius. On this third line, if you take 2 times 4, you're going to get 8. So I said the perimeter is equal to 18 plus 8 pi divided by 2. If you take 8 pi divided by 2, you are going to get 4 pi. So then on this final line, all I'm going to do to get the perimeter of this entire figure, I'm going to plug into my calculator 18 plus 4 pi, and on your calculator, you're going to get a value that says 30.56637 with some other values listed. And if you round that to the nearest tenth, that is going to give you a value of 30.6. Again, there's no units listed, so we're just simply going to say 30.6 units. All right, and here we go on the next problem. So I want you to look at this figure, and I want you to ask yourself, what shapes do you possibly see that make up this figure? Go ahead and pause the video and ask yourself that question. Okay, so there's a couple different ways you can approach this problem. I think a lot of students probably see this composite figure in 3 shapes. They may see a rectangle right here, a triangle right here, and then a half circle right there. That's definitely one way you can approach the problem. A second way that you can approach the problem, and the way that I'm going to show you, is if you simply split this shape into 2 different figures. Those 2 different figures being, if you drew a line right here, that would turn this into a trapezoid, and this would of course be a half circle. If you think back to your notes from before spring break, we learned that the formula for the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So I want you to pause the video and see if you can go ahead and plug in these values for this trapezoid right here at the bottom of the figure. Okay, so this is how you should have set it up. You should have said 1/2 times the first base is 32 millimeters, the second base is 20 millimeters, and then the height is 14. And you can go ahead and plug this into your calculator just as it's written here. Make sure that you use parentheses around 32 plus 20. So go ahead and pause the video and throw this in your calculator. Okay, if you did your math correctly, you should have gotten exactly 364. So 364 is the area of this trapezoid, 364 square millimeters. The second thing we're going to have to do, we need to find the area of the half circle or the semicircle. So I didn't do a very good job of drawing a half circle, but that's what these notations or symbols are supposed to represent. Of course, as we learned on our first page of notes today, the formula for the area of a circle is pi r squared. But again, because this is a half circle, we are dividing pi r squared divided by 2. So on this next line, I have pi 10 squared divided by 2. If you're asking yourself, where did 10 come from? Well, the diameter of this circle is 20, therefore the radius is 10. If you square 10, 10 squared is going to give you 100. So on this next line, I wrote 100 pi divided by 2. If you take 100 divided by 2, you're going to get 50 with a pi with it. And then the very last thing you're going to do to find the area of this entire composite figure is, in your calculator, you are going to plug in 364 plus 50 pi, and you're going to round that to 1 decimal place. And if you do that, you should get approximately 521.1 square units is the area of this entire composite figure. Okay, the next thing we're going to do, the last thing we're going to do on this problem is we are going to find the perimeter of this entire figure. So I want you to pause the video and think about how you could find the perimeter of this entire figure. All right, so here we go. We're going to find the perimeter of this figure, and then we're going to be done with this problem. So the first thing I asked myself is, I said, do we know any of the exterior sides? Because that's what we're going to need to find the perimeter and then the circumference of this half circle. So of course we do know a couple sides. We know this length right here is 14. We know the entire bottom is 32. So right here I said known sides. 14 plus 32, that is going to give us 46. So right off the bat, we have those two sides. That's really good. The next thing I said is, where are the pieces that we don't know the side lengths? So one of those pieces would be right here, this part of the triangle. We do not know this side length, and we need that in order to be able to find the perimeter of the figure. So you may notice that this looks like a right triangle, and it is. I know that this red dashed line is 14 because it matches up with this piece over here. I know that the length of this leg is 12 because if you take 32 minus 20, this piece up here, it's going to give you 12. So then I said to myself, I'm going to use the Pythagorean theorem to find the hypotenuse. So I've already set that up here. I said 14 squared plus 12 squared equals c squared. So you can go ahead and just pop the 14 squared plus 12 squared into your calculator. And if you do your math right, I believe you are going to get 340 equals c squared. And then how would we solve for c? Well, we would take the square root of both sides. So c is going to equal rad 340. Now, normally we would need to simplify rad 340, or we need to ask ourselves, are there any perfect squares that go into 340? But because this problem is only calling for an approximate answer, we don't need to simplify this. We can just leave this as rad 340, and then we can plug it into our answer at the very end. Okay, so then the last piece of the puzzle that we need, so we just found that this side length is rad 340. The last piece of the puzzle we need is, we need half the circumference of this circle. Well, one of the ways you can express circumference of a circle is diameter times pi, which is what I've done right here. But because we only want half the diameter, because it's a half circle, we are dividing by 2. So I said diameter times pi divided by 2. What's the diameter? Well, it's 20. If you take 20 divided by 2, you are going to get 10 pi. So then the very last thing you're going to do to find the perimeter, you're simply going to go to your calculator and you're going to add rad 340. Actually, what I would recommend that you do is, I would find the square root of 340. Just go ahead and turn it into a decimal number on your calculator and leave it in there. So when I do that on my graphing calculator, I get approximately 18.43. That's for rad 340. And don't round the number in your calculator, just leave it as it is. You're then going to add 10 pi to that. And then after you add 10 pi, you should have about 49.85. Then the very last thing you're going to do, you're going to add 46. 46 represents the 2 known sides that we had at the very beginning. And if you've done all of your math correctly, final answer should be, the perimeter is approximately equal to 95.9 millimeters. Okay, great. Okay, we're going to do this last problem. I know that notes have probably seemed like they've been kind of long today. and you're thinking to yourself, oh no, not another problem where we have to find the area and the perimeter and do a long calculation. The good news is on this last problem is it's actually a fairly brief problem, and the only thing we're being asked to find is the area. It's a little bit of a tricky problem because it's asking for, it says the area of the shaded region only. So only the shaded region. So I want you to pause the video after I get done asking this question. And that question is, how could you find the area of the shaded region only? So go ahead and pause the video and see if you can figure out how to start this problem. All right, I hope you were able to get at least a little bit of a start on finding the area of this figure. I know the first thing that definitely jumps out at me is that I see that the shape on the outside is a square. I know that it's a square because this side length is 10 and this side length is 10. So the first thing I say to myself, I say, you know, it should be fairly easy to get the area of the square. The formula for the area of a square is just simply base times height. So in this case, it would be 10 times 10, and 10 times 10, of course, is 100. So just like that, we've already found the area of the square. Unfortunately, it's not just a regular square. It has some portions that are cut out of the square. And of course, those portions look like circles. In fact, there are 4 circles. So next, we are going to need to find the area of each of those circles. So I said, this kind of looks like area of 0, but this is area of one of the circles is going to be equal to pi r squared. Well, the radius of one of these circles is 2. So if you plug 2 in right here, 2 squared is 4. So the area of one of the circles is 4 pi square inches. But as we can obviously see, there's not just one circle, there are 4 circles. So therefore, we're going to take this value, the area of one of the squares, and we're going to multiply it by 4. So 4 pi times 4 is going to give us 16 pi. That represents the area of the 4 squares. And then the last thing we're going to do, and this has been kind of a common student mistake that I've seen throughout the years of teaching this, is that students get here and they're not sure whether they should add 116 pi or they're just not sure what to do. Well, because you are trying to find the area of the shaded region only, what you are going to do is you are going to take 100. That's as if it was a complete square, the whole thing, but it's not. So you are going to take 100 minus 16 pi, which represents the portion that is cut out of the square. So go ahead and pause the video and throw this into your calculator, 100 minus 16 pi. If you've done your math correctly, you should have gotten that the area is approximately equal to 49.7 square inches. Okay, just a couple of final reminders here, and that would be make sure you do the homework practice problems. You do not submit those problems to your teacher. You just simply do them on your own, and then you check the posted answer key on Canvas. There's also going to be a Delta Math assignment that is kind of an advanced assignment if you want more practice, but it is not graded. The only thing that's going to be graded this week is a quiz we posted at 8 a.m. Thursday, and then that quiz is due by 5 o'clock on Friday. All right, if you have any questions, make sure you reach out to your teacher or you stop by their Zoom office hours. Thanks.